Hello guys, from the photo of the GPS antenna you provide, I put down simple schematics and I hope I didn't make some mistakes this time. The antenna is composed from the patch antenna and the two active devices, transistors, amplifiers, and the filter in between. The antenna is power supplied through the coaxial cable you're using to extract the RF signal. So the DC is coming, I assume 5 volts through the cable up to this point. And this is a simple bias T made from a quarter lambda microstrip line and a C8 capacitor. The transistors used in the GPS antenna are 2SC5508, marking T79, with the standard figures, noise figure 1.1 dB, gain 16 dB. Collector emitter voltage 2 volts and collector current 5 milliamps. To meet this criteria, we need to reduce 5 volts to the 2 volts, and for that we are using R3 resistor. I calculate that this resistor value should be 300 ohms to have 2 volts on both collectors. The transistors are biased through the R1 and R2 resistors. So doing the simple modification, removing the filter and DC coupling the stages, using just a simple wire, what is going on? So in this point we have 2 volts. The 2 volts we will couple to the base of the Q2 transistor. If we look the maximum ratings in the datasheet, emitter base voltage as a maximum value is 1.5 volts. Applying the 2 volts on the base, we will kill the transistor K2 for sure. Now killing the transistor Q2, this transistor will not probably draw the current anymore. This is just one case, just one possibility. In this case, the drop of the voltage on the R3 will not be any more 3 volts, but just half of that, 1.5 volts. And the voltage on the collector will be now 3.5 volts. The maximum allowed value is 3.3 volts. It means that we will kill most probably also the Q1. Thus, doing the modification by using a simple wire will most probably kill our GPS antenna amplifier. The better thing is to use the capacitor in place of the filter. 100 picofarad should be okay, and this should bring you working antenna with not so high efficiency and a 2-stage amplifier delivering 32 dB on the L band. The input of the amplifier after the patch antenna is DC coupled to the ground. It's a kind of ESD protection, but also this circuit together with the C9 gives us some selectivity. So this amplifier will not deliver a maximum gain all over the range, let's say from the 700 MHz up to 2 GHz, but will give the best performance on the L band. So that's it. I hope you understand the problem doing the simple modification for the presented GPS antenna. Thank you. 984 Queen Vector.